Alright, here's some binomial questions, and it gives you the x variable is following a binomial model. The number of trials is 6, and p, the probability of success, is given down here. So I'm going to do 3 questions. First one is probability of 0.5. Part 1, find the mean and standard deviation of x. Now if we go over to the calculator, this is actually given in the formula book. Alright, so binomial distribution with these parameters, n and p. The mean is given as this, n times p, and the variance is given. Now there's a link between the variance and standard deviation given by this, okay? So the standard deviation is the square root of the variance, okay? Or you could say that the standard deviation of x, let's just put that in a bracket. So basically standard deviation squared, well, let me just put this into the bracket so it looks nice and neat. Okay, so standard deviation of x all squared equals the variance of x. Okay, so that's just measures of spread and the connection with each other. So actually I can answer this question because n is 6 trials, and p is 0.5. So this first answer just becomes 6 times 0.5, which equals quite easily 3. Okay, and this next one is then 6 times 0.5p, and then times 1 minus p, which is another 0.5, which turns this into 1.5. But remember, that's for the variance, the formula, so we need to then put a little square root over all of this, control square root, and I'll just put this inside here. Okay, so that equals then to the square root of 1.5, and then we can just look at our calculator. Square root of 1.5 equals 1.22. I think I've got my calculator rounding to 3 sig fig. So this is 1.22. Okay, so you can see you can get the mean and the standard deviation each time just by using the specific formulas. But I want to do this actually the long way as well. So here I'm going to put my x values here, and I'm going to put the individual probabilities here. So I'm going to put down the probabilities of these number of successes. I'm not going to call it P, I'm just going to call it a different letter. I'll call it T. So if we have 6 trials, we could get 0 success, 1 success, or we have 6 successes. Then we want to work out the individual probabilities in here. Now, of course, we could work out individual probabilities on a calculator page, menu, probability, distribution, Binomial PDF, number of trials 6, probability of success 0.5. If you leave this blank, you are going to get all the probabilities. So this is the probability of 0 success, probability of 1 success, right? We have to scroll on a little bit to get all the probabilities from 0 to 6. But it'd be nice if those probabilities kind of appeared in this table, and you can get them appearing here automatically. So rather than just copying and pasting across from here, we can get them to appear in the spreadsheet by clicking on this row. So you can see this row has an equal sign next to it. These x and t are the column headers, the variables. Now in here we're going to enter a formula. So we're just going to type in menu, statistics, distribution, and we're going to do binomial PDF again. So it's exactly the same steps. 6 trials. The probability of success is for the 1 trial 0.5, and then the x value, we're going to type in x and watch the magic. Brilliant. So we've got actually the probabilities for 6 successes, the probability for 5 successes. So in the formula section here, look what we entered. We entered this x, which was really important because the x at the end takes these x values from the first column. Okay, so beautiful. When we press enter, it asks for a column reference or a variable reference. Well, the x refers to this variable in column A, so this is a variable reference. Now finally, menu, statistics, stat calc, 1 variable stats, 1 list, the X list is the X, and the frequency list is the probabilities, right? That's T. Go. It's going to say 2 or more arguments with matching dimensions. So, oh, look what, I haven't actually named this. Okay, so I need to label this column something. I think when I put the formula in here, it got rid of the column header. So if I just put T in there again, oh, but look, you can see the T's bold, so it looks like I've used T somewhere else already. So I'm going to leave that. I'll just call it, why not J? Okay, press enter. And now let's try again. Menu, statistics, stat calc, one variable stats, one list. The X list is X, and now the frequency list is this J. Off we go, and now look. So the X bar is the mean, 3, which corresponds to what we had written down here, 3. And go back to the spreadsheet here. And if you look at sigma of X, this is the standard deviation, which we've got 1.22, and which we also had here, which is 1.22, right? So for sure, using these formulas, super quick to get the mean and the variance, but using the spreadsheet, also really important that you have this skill, because now look, you can just read off the probabilities of each individual value, which is good. But then don't forget, we can just do this automatically just on a calculator page. If we want to finish off the questions now, if you think about part B and C on here, the only thing that's going to change now is the probability, 0.2, and the probability 0.8. So let's change those. I'm going to go back to the spreadsheet, click on the formula, and then you can just go back and change this to 0.2, enter, and we want to overwrite the data. And now look at this, the X bar, the mean has changed to 1.2. And the standard deviation has also changed as well. Oh, I think I've just overwritten that. That's okay, let's just go back and do the full button pressing. So I always go right to the start again, then move along to the first available space here. Menu, statistics, stat calc, one var statistics, okay. The X list is the X values, and the frequency are the J values, okay. We'll overwrite the data, and there we go, X bar, the mean is 1.2, and the standard deviation is 0.98. All right then. I suppose the next steps are we could draw a little graph of this, right? A column graph is what it's asking for now as well for part 2. Graph the distribution using a column graph. So this is just like a little line graph. X is 0, 1, 2, 3, 4, 5, 6. And on the y-axis are the probabilities, 0.262. So when you have a little look at the shape of these, you'll see a certain amount of what we call skew. There's higher probabilities towards the left. It's more likely that you get 0 and 1 success. And of course, the shape of the graph will change when you have different probabilities. Okay, so hope that helps.